Hello guys, and welcome to another video. So on this video we'll be looking at this question 2. So let's get right into it. It says a 40 kg metal box is pulled across a rough horizontal surface with a force of 250 newtons acting at an angle of 30 degrees to the surface. The frictional force acting on the metal box is 150 newtons. 2.1 says draw a labeled free body diagram showing all the forces that are acting on our object. Okay, so when you draw the free body diagram, guys, you firstly check the marks, and in this case we have 4 marks. So that means we have how many forces? We are going to have 4 forces. When you draw your free body diagram, obviously you use a dot as the actual object. Then you indicate firstly the visible forces. Visible forces are the ones that you can see. That's going to be this F. Then we have this one here. Which one is this one? It's going to be the force of friction. Then after that you focus on the invisible forces. The invisible forces in this case will be my force of gravity, or you can say weight. Then we'll also have the normal force act in the upward direction. Your lines must obviously be straight, guys. I'm not using a ruler, hence mine are not straight. But this is how you draw your free body diagram, and you get a mark for showing the dot and then showing the arrows, the direction of the forces, along with the correct actual forces. Okay, so that's how you answer 2.2, and then 2.1. Now we go to 2.2. So for 2.2, they say state Newton's second law of motion. I'm gonna quickly state it for you guys and then just open it elsewhere for you to look at. Then we'll pause the video to write that definition. It says when a net force acts on an object of mass m, the object will accelerate in the direction of the net force, where the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So that is Newton's second law. I'm just gonna open it elsewhere on the exam guideline for you to look at, and then hopefully guys you're gonna memorize that definition. Alright guys, so this is Newton's second law. It says when a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of the object. It's exactly how I stated it, so you guys must know it exactly as it is provided to you. Do not change anything, do not summarize the definition, just give it to us in full. And that's how you define Newton's second law of motion. Okay guys, so we are done with 2.2. Now we look at 2.3, and it says calculate the magnitude of the acceleration of the metal box. And wherever they say acceleration, this is what we must think. For 2.3, we must think that F net is equal to ma. Remember, you get a mark for this, but if you just write the formula without substituting into it, you are not going to get any marks. Even the formula will be marked incorrectly, and then, or rather wrong. Then from there guys, we are gonna check the information we have. Okay, we are gonna check the information we have, and this is the information that we have. The information we have is that we have this friction here, and we also have this applied force. But this applied force is actually supposed to be having its component do the work, and this component force will be 250 cos 30 degrees. So this force here, guys, does not, okay, yeah, this is the force that gets the object to be moving. It's our component force, right? It's our horizontal component force. It's the reason why the object is moving horizontally. Okay, now let's answer that question. So for us to answer here, guys, we are gonna write all the forces that are available to us, and the first one is the component, which is 250 cos 30 degrees minus the force of friction, and we saw that the force of friction is actually what? It is F. Yeah, let me just fix here. Our force of friction, yeah, is gonna be, okay, why did I write F? Our force of friction, guys, is actually 150, remember, is equal to our M, which is the mass of the object. Let's just go up to check. The mass of the object is 40 kgs multiplied by A. But because we are looking for the acceleration of this object, it means we are going to divide by 40 here on both sides. Then these will cancel. Therefore, A is equal to, I believe I want to set 1,66 meters per second. So what we are going to do, guys, is to confirm this answer, remembering it from my class. So we'll take this whole thing as it is and then put it on the calculator to find the answer. Okay, so on our calculator we'll say 250 cos 40 minus our force of friction, which is 150, and the value we are getting is, oh no, we're supposed to, my bad, guys, can I just switch things up here by adding a fraction? No, it's not working. Okay, we are supposed to add a fraction. Remember that what we are doing is taking all, we are taking all of this and dividing it by 40. Okay, because we are looking for what? For acceleration. So I'm going to say, sorry, 250 cos 40 minus 60 divided by 40. Okay, something is wrong. I don't know what. We'll just double check. Oh, it's here. My bad, guys. Here it's supposed to be 150, but I'm getting a different value as well here. I don't know. I'm not getting that one. Alright, guys, I just checked the answer with my other calculator and it is supposed to be 1,66. So I don't know what's wrong with my calculator. This one here. Let me just do this thing again. We have 250 and we have cos. We should be having cos. Is it 30 degrees or is it 40? It's 30. Cos 30 degrees minus 150. Then we divide by 40. Divide by 40. And yes, I think I made a mistake with the angle. I wrote 40 instead of 30. But you can see that our acceleration is 1,66 is meters per second squared. So that's the answer that you are supposed to have, guys. So this answer here is correct. Okay, now let's go to 2.4. 2.4 says we have to find the normal force. Let's find the normal force. Okay guys, so for us to find the normal force, we'll realize that this is a pulling force at an angle. So that means the normal force here is equal to Fg minus F sine theta. And then when we substitute, firstly we'll change this. This is going to be mg minus F sine theta. And our m in this case is 40 multiplied by our g, which is 9,8, minus the F is 250 sine our angle is 30 degrees. Then we'll take all of this and put it on the calculator. So on our calculator, we will have our mass. Let me just switch it. So we will have our mass, which is 40 multiplied by our 9,8, lose this, minus 250 sine 30 degrees. And the answer we are getting is 267. So that's what we'll have for our answer here. So our normal force is going to be 267 newtons, and that's how we are going to get our answer there for normal force. Now we go to 2.5. So the last question, 2.5, guys, says it starts here. It says the box continues being pulled with a force of 250 newtons at an angle of 30 degrees to the surface, but the box now slides up an inclined plane. Will the frictional force acting on the metal box increase, decrease, or stay the same? Briefly explain your answer making use of a relevant equation. So before we go any further, we'll realize that if, guys, our object was initially on an incline, let's say, or rather on a flat surface, and now it's on an incline, that means this is how our object will be, and it will be pulled at an angle there of 30 degrees. The force of friction will still act in this direction there, and this will be our F applied, capital letter F. And here, guys, what you will realize is that if we are having this angle here now, we are from 0, because remember when the object was on a flat surface, there wasn't any angle, but now the angle has gone up, right? And if the angle has gone up, what does that mean? That means that my normal force will actually decrease. And why is this happening? It's happening because we've talked about the relationship of the angle and the normal force being inversely proportional. And this means that if I have an increasing angle, my normal force should decrease. And now I'm going to look at the normal force and friction in terms of their relationship, and it's directly proportional. That means if I'm now going to have my normal force decrease, my force of friction should also decrease. So my answer here is going to be decrease. But they said we must use an equation to explain this answer, and our answer will come from this here. And we know that based on this equation, if the coefficient of kinetic friction is constant, then the relationship between the kinetic friction and normal force will be directly proportional. So because I'm having a decrease in my normal force, I should also have a decrease in my force of friction. But we can also look at it in this sense that if I have my object being, or rather acting at an incline, that means I'm going to have something like this when I'm drawing a free body diagram. This will be my force of gravity. This will be my friction. And this will be my normal force. Just straighten up my line. This will be my normal force. And if this is the case, guys, I'm going to have what we call component forces. Here I'm going to have FG parallel, and then this side I'm going to have FG perpendicular. But when I check this and this is the normal force, remember? And we know that the normal force is equal to the force of gravity. But in this case, when we are on an incline, the normal force is equal to the FG perpendicular component. And this FG perpendicular is equal to what? It's equal to mg sine. Is it sine? Let me just remember. Yeah, it's actually not sine, guys. It's cos. Yeah, I'll explain why it's cos in another situation. But for now, all we have to know is that FG perpendicular is equal to mg sine theta. And if this is the case, that means our normal force will be equal to mg sine theta. And what is this theta? Is this angle here, which is the angle that we're making up. We don't know the actual angle. But that means, guys, if we substitute into this formula, our normal force will actually decrease. Let's come up with any angle. In fact, let's say the angle here is maybe 20 degrees. And check if the normal force will be the same as the one we had gotten previously. Remember that the normal force we got here was, what was it? Was it 267? So here my mass is 40 multiplied by 9,8 multiplied by sine. Let's say the angle is 30. Here, guys, it's supposed to be cos, not sine. I don't know why I'm making this mistake. Yeah, it's supposed to be cos there. Cos theta. So if we substitute into this, and we are saying our angle here for argument's sake is 20 degrees, let's compare what our normal force will be. Let me just find my calculator. So on my calculator, I'm just going to change a few things. This is cos, and then I'll put 20 here. And my mass is still this. Do you notice that if my angle is 20 from 0, though it has increased, I can put any number. In fact, I can even put 30. But the more my angle increases, the lesser the normal force I have. Let me put 60. Okay, 60 gives me the same normal force. Let me put 70. Yeah, I don't know how to put this, but yeah, let me just use 20 because I don't want to confuse you. Because my angle increased from 0 to 20. By the way, this is an angle I made up. That means my normal force will be affected by doing what? By decreasing. Okay, so if the normal force decreases, that means the force of friction will also decrease. Okay, this is just additional learning, guys. I'm gonna be going through this properly in the other videos. I was just trying to show you what happens with the normal force if we increase the angle from us being on a flat surface to us being on an incline. And yeah, your answer is based on this basically, and then it should be decreased. If you had any confusions, they can just ask me whatever questions you have on the comment section, and then I'll help you out, guys. I'll see you in the next video. Bye.